Good morning, 7th grade Wesleyan students. Today for our iLearn question, we're going to be taking a look at the standard on number sense, 7NS3. Know there are rational and irrational numbers. Identify, compare, and order rational and common irrational numbers and plot them on a number line. So for your question today, it will be 3 numbers are given. Place each number at its approximate location on the number line. While testing, make sure there is no talking, that you're staying seated, and that there are no passes in or out of the classroom. You're working independently on your question and showing all your work. And when you are finished, do not move on until the time is up. We do not want to distract others by getting out books or coloring or anything else until the time is up. So everyone has the same equal opportunity to show their work and do their best. Make sure you write down the problem, show all your work. You have 10 minutes. You may begin. Time is up. Let's take a look at the answer. Are given, place each number at its approximate location on the number line. We first have to understand that our verb is place, and what are we placing? The number, and then where on the number line. Now we need to take a look at what numbers we are comparing. Since they are all in a different format, we must convert them to the same type of number. So we have a square root, a fraction, and a decimal. I'm going to convert each of them to decimals so that they're a little bit easier to compare. So at this point, then, the square root of 13, I have to ask, what perfect squares surround the square root of 13? That would be the square root of 9 and the square root of 16. So if we take a look at the square root of 9 and 16, we know that that is 3 and 4. But if we put all of the numbers from 9 to 16 as square roots and compare them, we'll be able to accurately, or more accurately, get a representation of where 13 falls between 3 and 4. So if we look at all of these as square roots all the way to 16, we see that 13 falls right here. And it is closer to 16 than it is to 9, so it must be closer to 4 than it is to 3. And if we look, we have 1, 2, 3, 4, and 1, 2, 3, 4. So right here is this middle. So this would be 3.5 right here, but 13 is behind that halfway point. So that means that 13 would be approximately 3.6. Now we need to look at 4 and 2/3, and to convert a decimal to, a fraction to a decimal, you can divide 2 by 3 and put in your place value. So 3 will go into 20 6 times, and we'll start to see that our 2 is repeating as our answer, or our remainder. So we are repeating a 6 as our decimal. So the decimal 2/3, this number is 4 and 6/10, but the 6 is repeating. And then 2.85 or 2 85 hundredths is already in a decimal, so we can leave it there. Now we can see that the 2 is the smallest, and then the square root of 13, and then 4 and 2/3, but we need to place them on the number line. So again, this number line is a snapshot of our values. So we can start our number line at 2, and then I'm going to count 1, 2, 3, so that gives me 1, 2, 3, 4, or 1/4, 1/2, 3/4, and then a whole, so there's my 3, and so then I can count 4 down again, and I don't have 4 left to get to 5, but I'm not going all the way to 5, so I should be okay. So if I start with the smallest at 2.85, again, this would be 2.25, 2.5, and 2.75 because I divided it into fourths. So 2.5 and 2.75 are right here, and 2.85 is greater than 2.75. So I know that my number could sit somewhere about here in front of the 3. Now my next number at the square root of 13 is 3.6. So again, if 3 is my whole number and here is my half, I know that it's just a little bit after the half, but not quite to the 7 or 3/4. So I have my square root of 13 here. And then for 4.6 repeating, I know that this would be my fourth, or my 0.25, and this would be my 0.5. So this one would be a little after my 4.5, because 2/3 is greater than 1/2, but less than 3/4. So that is how I would plot my